All right, so the last thing we're going to talk about is deleting by data. So we could also delete by index, and I'll talk about that in just a second. I just wanted to show you a different type of way that we can add or delete something arbitrarily in a list. So the value of a variable passed is passed as a parameter, and here it's going to be a string, right? Because that's the data type, basically, that our nodes possess. It's just a string called name. So we're going to pass a string in that we want to basically say that we want to delete the node that possesses that name. All right. So we're going to use a while loop, again, to traverse the list using the temp and previous node references that we talked about before. Basically, just using these until we find the node that contains that piece of data, whatever that name of that string is. That's where we're going to stop because we found the thing we want to delete. Or if the we run off the end of the list, if temp is null, then we know that the target node the name that we want to delete isn't even in the list at all, and we've made some kind of mistake, or we're trying to delete something that isn't there, and so we need to throw an error message. So let the previous node point to temp.next. Once we found, assuming that we found the node with the name that we want to delete, we let the previous node point to temp, not to the temp node, to the temp.next node. So we're kind of from previous bypassing around the temp node to the temp.next node. So this way, the target node, which is on temp, that's what temp is right now, the only thing referring to it is the target node. So once we reassign that target node, or sorry, let me backtrack. Right now, the target node, or the temp node, the only thing referring to that is the previous node, right? So if we take the previous node, the reference to the next from previous, and we change that to the one after the target node, then the target node doesn't have anything pointing to it anymore, and it's just going to float off into space and be collected as garbage. So hopefully this will make a little more sense. This is definitely the most complicated method we've talked about, but it's not too bad, I don't think. So first we're just going to check to see if the name we want to delete is at head. So we say if head.name.equals toDelete, with toDelete being the string that we pass into our method. We're just going to call delete at head because that's where it is, and we don't have to worry about anything more than that. Similarly, if the tail name, the name of the tail, it matches the string that we want to delete, then we just delete a tail. All right. Then case 3 is if that piece of information wasn't at the head or the tail, we need to actually find it somewhere in the middle of our list. So we assign make the temp in the previous node references and assign them both to head. And then we're going to say, okay, while temp does not equal null, right? While it still points to something actually in our linked list, and not temp.name.equals toDelete. So while we haven't yet found that node that we want to delete, basically these are the conditions. Either we found the thing we want to delete, or we've run off the end of the list. And if we haven't done either of those things, then we're going to keep advancing our temp and previous pointers or references. Kind of the same idea to what we were talking about before, just crawling over the list. So once we have exited this loop, right, either the temp is going to be null or the temp is going to be the node that we want to delete. So we're going to check, okay, if the temp is null, then we're going to throw our error saying, error, that name doesn't exist in the list. I couldn't delete anything because you gave me a name that doesn't exist. Else, if this is not the case, then we know that we successfully found that node that we want to delete. So then we're going to do previous, take the node previous to the one we want to delete, say previous.next equals temp.next. So then it bypasses the current temp node. Temp doesn't have anything pointing to it except the temp reference, but that will get deleted when this method finishes because it's a local variable. So as soon as this method finishes, the temp node is going to get deleted by the garbage collector, and then we can take our count down.